MZX Rules was kind enough to point out with a smile that what I thought I had found was the intro cutscene actually wasn't. Deku Tree is a scene, and this entrance belongs to this scene. So Deku Tree has 4 entrances associated with it. Like here's this overall definition for all the scenes and what should link together. And then at different areas in the code, like when we need to define what are all the scene IDs, well, we just import that table, but we only take this 3rd segment. Say hi to Gigi. Hello and welcome back. This is episode 5 of Code Spelunking, cracking the code, master questing, something along those lines. I'm still figuring out a name for this. But regardless, we are here today to dig into Zelda Ocarina of Time. Man, I've been excited for this episode. The last 4 episodes, well, the first 3 I had recorded before I posted any of them. 4th one, I had just seen the first episode start taking off by the time I recorded that, so I didn't really have enough time to dig into some of the responses, which have been incredible. Man, not only just the sheer positivity that people have been posting, but some of the folks, MZX Rules, Roaming, Yosefka, y'all have posted some incredible comments, like pages long at this point, in particular MZX Rules, and those comments have been invaluable. Invaluable for me as somebody who just decided, you know what, let's dive in, and immediately got deeply confused by a lot of stuff. So shout out to y'all. In fact, I'm going to look at some of those comments right now, and we're going to sort of break down some of the stuff that I was confused about before. So that's going to be fun. But yeah, I also want to talk a bit about what is this series. I'm sort of figuring it out as I go. But basically, this is about diving into the unknown. This code base is like the water temple for me. This stuff, I hadn't touched C in over 10 years. I touched it in college, but it's not like real practical use that, you know, you have context for and you have developers to sort of explain some of these things. It's just like those assignments that you do. And it's just been so long. I've had to refresh on a lot of concepts. I'm a full stack web dev today, for full context here. Been that for a few years now. Before that, I was a C# dev. I worked on MS Build, so if you've ever used Visual Studio, full-on Visual Studio, to build basically any project that can be built in there, that thing is heavily tied to MS Build. Any .NET project is heavily tied to MS Build. That was my second full-time job. Before that, I had a brief stint with Ada, which I didn't enjoy that much, but here we are. So yeah, like the stuff that I've worked with is generally a lot higher level. I learned programming basically through C#, so looking at a lot of this lower level code has just been a great learning experience. Going back to the people who have posted comments, thank you. Like, man, I can't put into words how grateful I am that people have taken the time to really explain some of these things. So I want to do that justice by going over some of that today. But before that, even more important news, I busted out my old 3DS. I actually started playing Master Quest. I just beat Lord Jabu Jabu. That dungeon is insane on Master Quest. I feel like Master Quest doesn't really show itself until that dungeon, where they really remixed it. They started throwing, there's just a bunch of cows in there, and you have to shoot these cows with your slingshot, and like treasure chests fall out of nowhere. It's so random. It really feels like a mod of Zelda, which I guess is kind of exactly what Master Quest is. It's great seeing they had a lot of fun with it. But yeah, I just became an adult. But yeah, some other folks had commented that they started playing Master Quest. That sort of got me back in it, man. This game is so good. Oh my god. I have not played Ocarina of Time since beating it on the 3DS. Maybe? Oh my god, was it 10 years ago? A long time ago. And before that, it was like me playing it as a kid. So yeah, if you're not playing Zelda and it's been a long time, I invite you to also just jump in. Man, it plays great. I cannot wait to get into some of that gameplay code, specifically how they do stuff with the camera. The camera does a lot of work. Like when you're standing on the edge of a cliff, the camera just sort of pans down so you can see what's down there, right? They do a lot of really smart things. Yeah, so we are here. Where are we? Let's put on some music. Let's do this. Yeah. All right, now let's get into the code here. So I need to refer back to a bunch of comments folks have made. First and foremost, Yanis on the Discord. Thank you for showing me that there's a VS Code document here that actually helps folks who use VS Code get set up here. So I've installed a few of these things. Hex Inspector I expect to be very, very useful. And something I've already found is extremely useful is this C++ configuration. So basically, I want to look at something that confused me earlier. So when I first dove into main, I think I scrolled at the top here, and I just started going to definition on stuff. So this S32. Without that configuration, if I go to definition, it's not actually going to take me to the definition of an S32. Instead, it took me to the definition of a DMA handler, which I also want to break down because there have been some super useful comments. But first, this S32 thing was sort of the beginning of me getting confused on stuff. So I have the configuration file here. I'm going to drag this over to the VS Code folder. If you're looking at this code base, you sort of need this. Just get this, basically a JSON file. You use the command edit configurations in JSON. If this file doesn't exist, it'll create it for you. Then you just copy all of this into that file. There's also apparently some search settings you can bring in. So I brought those in as well. That just goes under VS Code settings.json. You just add another section over here. So huge shout out to Yanis. So now with that in there, I'm gonna go to definition on S32, and there we go. It actually takes me to the right place. All right. Now I want to actually remove this file again and then go to definition. Okay, so let's look at this definition. Yosefka was pretty great in explaining how exactly that worked. So in reading up on C, I found something called the clockwise spiral rule, which I've seen people sort of nitpick here and there, but this was enough for me to get started in starting to understand some of these variables here. So basically, you start with the thing that you want to make sense of. In this case, it's str. And then you sort of go in this spiral motion and you make sense of it. So str in this case, str is an array of 10 of pointers to characters. Okay, so I guess each one of these is a pointer then. That's very interesting. That's something I'm still getting used to. So this DMA handler here, this is, if we do the spiral rule, and that spiral rule parentheses have to be solved first, this is what we're defining. We're defining a DMA handler. It is a pointer to a function. Now, this function returns a signed, what is it, signed long? Yeah. So shout out to Yosefka, who they themselves mentioned that pointer syntax in C is miserable. Okay, so next on the list is, how does this program actually start? MZX Rules posted an incredible comment. Okay, so MZX Rules says CPU execution actually starts at ASM routine entry point, and that exists in entry.s. So I'm gonna go to entry.s. Entry.s does have this entry point. There's something called a leaf function, I think. It's probably not the right term. But in here we see this boot proc. And this does not, make perfect sense to me or anything, but boot proc then creates the idle thread. So there is a function somewhere called bootproc. I believe I saw it in that first video. So bootproc is here. So from, I suppose, these instructions, we end up in bootproc. If we go down here, we have this OS create thread. That creates the idle thread. If you remember, there's main thread entry and graph thread entry. So idle thread entry does a lot of logging and initializing of some stuff that I'm not going to dive into. But over here we have another create thread. This thread calls main thread entry. Way down over here, it finally calls main. So main wasn't actually the starting point of Ocarina of Time. It's this entry point, which then leads into bootproc, which then leads into idle thread entry. This is the idle thread, which then creates the main thread entry. Now we're running that. Calls main all the way down over here. And then we start graph thread entry, which somebody had pointed out that graph is short for graphics in this case. There is no actual graph involved in this, and I suppose that makes sense. Like, I haven't actually seen a graph in here. I just sort of assumed that this was a graph that we were sort of navigating between like game states, but makes sense considering graphics is all over this. All right, so what is next? Then we get into the game loop. So we get to graph update, which updates the game state, which calls main. Main gets set when we initialize the current overlay. Setup underscore init is the first one. Then we get into the implementation. That's what impl is short for. In the implementation, we go to console logo. Console logo, we set console logo's main. In console logo's main, we do all the stuff to draw the logo, and eventually we will figure out when to exit. And exiting will take us to title setup. And this is the beginning of like that opening cutscene. This is the setup for the opening cutscene stuff to happen, because in here we set Link to be an adult. We set the game mode to title screen. We set this cutscene index, which is yeah, so this is a nice little extension that was recommended in that VS Code doc, where I can hover over a hex number and it'll give this little pop-up. Now I think this is going to be most useful to show me not the decimal version of the number, but the binary version of the number. Because as we start to talk about these cutscene flags, Joe Jody had mentioned, I had seen this number sort of everywhere, and this number, 65520, that this number doesn't necessarily mean anything. What does mean something is the binary behind that number. So every single one of these Fs here represents 4 ones. So here's the first 4, that's the first F. The second 4 is the second F. The third 4 is the third F. And the 0 represents the last 4 bits here. So basically, it seems that when all of these bits are set, that means we're in a cutscene. And then the last 4 determine like which cutscene we're on. MZX Rules went into great detail about a lot of this. So I'm hoping to refer back to it as I actually dive into the new the cutscene stuff that I'm going to dive into today. So that's really, really fascinating. I think that's a key thing to understanding it. Scene layer. Scene layer is something that MZX Rules has explained to me. That basically, imagine Link standing in the town center for Hyrule. That is a scene. That scene has layers that can be like overlaid on top of it, essentially. Those layers would be, are you Kid Link? If you're Kid Link, the town should be happy. Are you Adult Link? Then the town should be filled with zombies. Is it nighttime? Is it daytime? I have yet to really dig into that, but MZX Rules has been kind enough to explain some of that logic that I'm sure I'm going to get into. Okay, so from setup title screen, we get into play in it. So if you recall, my big discovery last episode was that opening scene is a cutscene. That cutscene runs like in the play mode of the game. So it's not like that's a special scene that's separate from the game. That is part of the game, and the game is just playing a cutscene. Which is very interesting. So in play in it, we set play main somewhere. Dot main equals. There it is. Alright, so state main equals play main. In play main, this is the update function. We go into play update. In play update, we get into... Oh boy, where was it? It was like, I need to put a bookmark. Where it is, here it is. Bookmark toggle label. Let's just put cutscene update method. Alright, now here is where I started learning a lot last time. Let's change the song. Let's start with the Deku Tree. And then as we get further in, we can mix it up. Okay, there are two more things I wanted to point out. One of them is Zelda Z. Zelda Z is what's called a magic number. And a magic number, when you're saving a file, files are in specific formats. When you're reading a file, you need to make sure that that file is valid, especially if it's a save, because you don't want to load corrupt data into your game. My understanding right now is that Zelda Z is the first batch of characters in that file to make sure that it's the sanity check. Does this file start with Zelda Z? If so, we know that this is a valid save file, or at least we hope, because if there's any other like mangled data in there, then we know it's invalid and we can't load the file. This is actually a very common concept. There's one for tons of formats, like bitmap starts with BM, PNG format starts with .png apparently. There's a lot of these sort of magic numbers. So yeah, shout out to a lot of people who pointed this one out. David Bungard, Valshaped, MZX Rules, David CR96, Danny Noon, IGN Awesome. Like, yeah, a lot of people were aware of that one. And I was not, but thank you for sharing that. And the last thing I wanted to go over was that empty do while loop. Where's the game state table stuff? So set next game state is a macro, which basically means wherever we call this thing, it looks like you're calling a function, but what's really happening is it's literally just replacing whenever you use it. Like right here, we do this set next game state. Well, it's literally just replacing that with this code right here. So they intentionally remove that semicolon so that right here we have to put a semicolon so that it looks like normal code. So shout outs to MZX Rules again, and Minty Neo for pointing that one out. Seriously, a big thank you to everybody who's just placing corrections and knowledge in the chat. That's it. It's the reason why I want to now do these. First of all, I want to do these weekly, and second of all, I want to post these like in real time, so that for the folks who are actually following along each week, first of all, I get useful information and then I can use it immediately in the next video. But also to join on this together. This is a lot of fun. I'm excited that people are excited about this. So let's go on this adventure together. There are a lot more comments, but I cannot cover them all at the same time. I think this is a good start. So anyway, let's get back into cutscenes. Yes. All right. So today the focus is cutscenes. My goal is to see how the opening cinematic works. And I know how we get into it. I know how. I know that it is a cutscene. MZX Rules was kind enough to point out with a smile that what I thought I had found was the intro cutscene actually wasn't. What was it? G. Let me look for it. Well, I'll find it. Let me get back into this. So, update scripted runs in play update. This runs for every single frame. In update scripted, we set up scripted, which loads all of the commands, I believe. We run the script. Wait, before this is a process script, isn't it? On the script. Yeah, so here's that cutscene flag, which, if you see, as long as our number is greater than or equal to all of these bits being set, then we know that this is a cutscene. Very interesting. Right, we increment the frame, process the script. The script loads all of the commands for this frame, I think. Right? Let's go back. So we incremented current frame plus plus. So somewhere in here we use current frame. Yeah. Okay. If we've passed the frame count, then we're done with this cutscene. Boop, boop. Okay, yeah, this is happening all the time. Frame logic. Wait, I somehow stepped out of the function I was in. Is it used anywhere else? Player queue. MZX had a lot to say about actor queues and player queues. That's going to be a very interesting one. I'm waiting to go over that comment for when I get there. Yep, lots of actor queues. Okay. All right. After processing the script, I think I really have to understand process script before I move on. But also, what was that file? I forget what file it was in, like all those commands. So I'll just have to work my way back. Let me step back. Finally, my back and forward buttons work. I had to rebind them. All right, let me. Oh, here's exactly where I wanted to go. FF3. So the cutscene index is 3. So I believe that this means that this is the third or fourth cutscene in, like, for this scene, maybe. Again, I'm still not 100% on how those things link up, but like the concept of scenes and layers on scenes and cutscenes, I believe, are like all intertwined. Yes. Okay, cool. Check this out. So we have a scene layer, and that scene layer changes based on whether Link is a kid and at night or in the day. Same with being an adult. Again, let's think about, like, we are in Hyrule Square. As a kid, you're going to see, as a kid in the day, you are going to see people dancing. As a kid at night, you're going to see less people. As an adult, during the day, you're going to see all the zombies, and I don't think there is a night difference of that one. I'm not sure. But the layer is like, it's almost literally a layer that you add to whatever the current scene is. Interesting. When entering Gerudo Valley in the credits, trigger the GameCube emulator to play the ending movie. Okay, that's pretty cool. Handle entrance triggers. Right, I think... Yeah, okay, here we are. This is where I got to. Okay, I thought this G Hyrule Field intro cutscene with all of these camera commands was the opening cinematic. I changed a bunch of zeros here, but I haven't gotten it to build yet. I gotta do that soon. So this is not the intro cutscene commands. This is what happens when, as a kid, you enter Hyrule Field for the first time. These are the camera moves that happen, because you get this, what is it called? You get an establishing shot of Hyrule Field the first time you enter it to see, like, whoa, this is a huge area, and the camera shows you the different points of interest. This is telling the camera to do that, which is awesome. So we know at least where these are, but we don't know where, like, the Link running on his horse happens. So I'm gonna put a bookmark here too. Entrance cutscene table. Yeah, I thought it was that because it was so close to this title demo destination. Which you would think makes sense. So where do we go next? We're kind of... We're not stuck, but we've got, like, multiple pathways we could go down. That's part of what makes this so interesting, is I could jump directly into the gameplay code right now. But I want to understand cutscenes. Fig in the Discord had pointed out that my answer for how that opening cinematic works is not going to be in the cutscene logic, which makes sense. But I do want to just get a general understanding of how cutscenes work. So, cutscene handlers. It seems like cutscenes go through their own, like, finite state machine, where nothing's happening. You're starting it, you're running it, you're stopping it, and I don't know what this unstoppable is. If I were to guess, I would say that this is like when a treasure chest shows up and you can't skip that because the game is really trying to show you, hey, the world has changed, so you can't skip it. Okay. How do cutscenes work? Back to play. Yeah, I guess the first time we would care about cutscenes is in Play In It. If our entrance index is loading. If we're loading the opening, we go back to title setup. Okay, -1, okay. Shooting gallery. Okay. Where do we check for this entrance load opening? Oh, interesting. Okay, file choose. This is a step after where I want to get to, but Entrance load opening. What is this function? Load game. Oh wow, this is like the load game. Load the save file for the appropriate game file. Load the save for the appropriate file and start the game. Okay. Yeah, not getting into this yet. Where else do we do this? Map select load game. Oh, I think this is that debug thing that was just mentioned. So it says on debug ROM, file 1 will go to map select. I assume that's this Z select. Suppose that would make sense. All right. So now where I'm trying to get to. Let me take this slow. We know that we get into play. We know that that opening cutscene is in play. We know that once title setup is done, title setup main, set up title screen. So set up title screen. Sets this cutscene to happen. We go into play. Entrance index. There is no entrance index set. Is there an entrance? Oh, okay, so there is an entrance index set. Hyrule field 0. Oh, yeah. MZX rules also had explained this. That, like, I don't remember it exactly. I'm gonna look this up. Because I can video edit this away. Okay, so here's how MZX had explained this to me on Discord. Each scene has a base layer. So for Hyrule Field, at least this entrance for Hyrule Field, is a base layer. And then what he calls loadouts are layered on top. So if Hyrule Field 0 is a base layer, then all of these are different loadouts? Different layers, maybe? Maybe this is the layers that he was talking about? So he says the easiest to follow is in Kakariko Village. So let's look at that. Kakariko Village. In Kakariko, you have NPCs that appear depending on which age the player is. So is that shown somehow here? I have no idea. Well, what is... Let's check out what defined entrance is. It's not very helpful. Oh, wait. This might be one of those defined in multiple places things. Just like defined game state. Like, sometimes defined game state is just the enum. Like this. Like, these are literally unused right here. But in this context, it is just the first value. In this case, Kakariko Village 0. Oh, that's how we get them all in. Oh, interesting. So when we're talking about entrance indices, we get this entire table. Hey, Dodongo's Cavern. So an entrance index is just an enum, just a number. And we use this entrance table to essentially strip away all this extra data and only get the first one. I'm going to read this comment in a second. So when this enum is getting defined, we're just including, remember the fact that this is a macro, and macros are just text replacement. So in this file, every single time they do define entrance, plugging in all these values, what this macro is going to do is just give us the enum. So that when we create this enum entrance index, it includes this file, which calls this macro a ton of times. How many lines of code? That is like 1900 lines of code of defining entrances. Now, remember that this macro, this is the definition of this macro. So enum is just the first one. So for every single one of these, it's just using all of the first ones to create this entrance index enum. That's pretty cool. Okay, now let's read that comment. Okay. Define entrance. Should be used for entrances. Is this visible? Maybe I should zoom in one. Yeah, I'll zoom in one. All right. Define entrance. Should be used for entrances. The first one is the enum value. Second is the scene that this entrance belongs to. So the Deku tree is a scene. And this entrance belongs to this scene. So, okay. So the Dodongo's Cavern is its own scene that has an entrance associated with it. So Deku Tree has 4 entrances associated with it. I don't know if the 0 one is also an entrance. Maybe MZX Rules had already explained that, but there's a lot here. There's a lot to rock. Argument 3, the spawn number for this entrance. These are all 0. All of it is... Okay, some of it has changed. Not sure what that does. Argument 4, toggle if the background music should continue during the transition using this entrance. Note, for non-cutscene layers, this field is only read from the scene layer child day layer. Okay, this is... You ever read something and then ask yourself, what did I just read? That's what just happened to me. I'm gonna move on to argument 5. All right, argument 5. Toggle if a title card should display when using this entrance. Oh, that's cool. Oh, interesting. I wonder if all the zeros then... Argument 5. 1, 2, 3, 4, 5. Okay, so every single one? 1, 2, 3, 4, 5. Not every single one, but a lot of them do. 6, transition type when doing it. Fade black, fade black, fade black. Okay. When exiting. Okay. This is making sense. Defining entrances. Here are the scenes for these entrances. I forget exactly what the third one is. The spawn number. Don't know what that means. The fourth one. Should the background music continue when using this entrance? In some cases, no. And in some cases, yes. Where is the yes case? Here. When we're in the back alley. Oh, I see. Is this the back alleys of the market? That makes sense. So we're transitioning to a different area. but that area is just a small area within this larger area, so we don't stop the music when we transition over there. Cool. Transition type when exiting. Yeah, okay. Due to how the entrance system is implemented, entries within the same group of scene layers are not shiftable. Okay. Okay. Well, here are the definitions for every entrance in a location. That's cool. Okay, here are all the scenes. Scene table.h. Do these refer to anything? No. Not that I can see. Labo scene. Test room. This is it's a pretty good song to play right now. Okay, define scene. Should be used for all scenes with or without a title card. See argument 2. Argument 1. Name of the scene. Segment in the spec. Okay. Oh, what is a spec? A spec is a file. That links to object files? Is that what a .o is? Oh, but now we're looking in the assets. This is the first time I've seen a spec file that has no extension. Okay, not sure what's happening there. Name of the title card segment in this spec. Where does this take me? 4 of these. Assets. I am assuming these are assets. Argument 3, the enum value for the scene. Yeah, okay. So we're defining a scene, like the Deku tree. We're saying what the name of this scene segment is in the spec, which is this file, which seems to point to an asset. Presumably that asset is the asset for the Deku tree in this case, or Dodongo's cavern. Oh, I see. I don't know what YD is, but DD for Dodongo's cavern? No? I'm trying to find some convention here. Ganon scene makes sense. End scene. YDAN boss scene. Oh, it's the Deku tree boss. Oh, that's a different scene. Guess that checks out. Mizu Sin BS scene for the water temple. Makes sense. Is Haka shadow in Japanese? Okay. Okay. Alright, well, here's where the scenes are defined. The scene draw config index. Who knows what that means? Okay, what's the actual macro for define scene? Okay, we ignore everything else, just take the enum. But when we define scene ID, we're only using the third argument. So we can refer to these scene IDs through this enum here. Okay. Now, I gotta imagine this is defined multiple times. There it is. Linker symbol declarations. When we define a scene with a name and a title, we declare ROM segments. Okay. Okay, so let's look at this. YDAN scene and GPN06. Alright, so this is defined 3 times. This is just like what Iosefka and I think MZX and some other people have pointed out, that these macros are defined in multiple ways, seemingly to reuse this same... to reuse the same data as many times as possible. Like, here's just this overall definition for all the scenes and what should link together. And then at different areas in the code, like when we need to define what are all the scene IDs, well, we just import that table, but we only take this 3rd segment. And that's what we're doing here, is ignore the 1st, the 2nd, the 4th, the 5th, the 6th, but just take that 3rd one when we're defining a scene ID. I won't make sense of that one right now. Scene table definition. So does something refer to this? ROM file. ROM file. Ooh. Look at the name. It's an unsigned integer point. Wait, I got a definition. This is an unsigned long, and this is a signed long. Okay, and long in this context is 32 bits, I believe. So an int pointer t, I don't know what the t is, but int pointer t is a signed pointer. Uint pointer t is an unsigned pointer. Okay. And a ROM file, it has 2 pointers. One for the start, one for the end. Unsigned. Okay. So, when we define a ROM file, this is what? This is an initializer for something. Probably a ROM file. Okay. So, ROM file is a struct. When we call this ROM file macro, it is going to replace whatever was inserted with this. But that name, we're coming back to, what was it, token concatenation? So it's going to take an underscore, and then whatever this name turns out to be, that's going to get placed here. And then it's going to combine that with segment ROM start. And yeah, so that's for VROM start. For VROM end, it is this one over here. And if we're unsetting it, then 0, 0. It's an empty file. Oh yeah, start and start. But if it's an actual ROM file... Okay, so then where do we use this ROM file? Alright, well, we use it here in this defined scene. Oh wait, where's the definition? Okay, for the name. Okay, and we know that when we define a scene, we take the name. The name and the title. Oh, I see. We declare them. Declare the ROM segments. Okay, hold up. We define this defined scene, and that will declare ROM segments, which is going to create a U8, an unsigned 8 bits array. So this is going to be an array of U8s, because it's not a pointer, right? Yeah. Okay, so we've defined this macro to do these 2 things with the name and the title. Then we include this scene table, which just brings all this code in here. And this is the name and this is the title. Name and title, and name and title, and name and title. So it's going to declare ROM segments for every single one of these scenes. And then we undefine define scene. And then we define it again to do something else. Now to actually create first, we got all these scenes and we declared ROM segments for each one. Okay. Now we're redefining it to actually load these things. Oh. That's interesting. Okay, so we define scene as, you know, it'll help if I just did this. Okay. So define scene basically does this. It creates 4 arrays. These are the same, these have the same names. Oh, but we're doing it with the name and the title. Okay. This is confusing because, okay, let me change this. Basically, what's happening is here is whatever title is when we call define scene, it's gonna replace this, and so we're gonna create an array of U8s, and the name of that array is going to be based off of whatever the title is. So if we go here, when we're calling these, like when, let's say this one is called. Let's go back. So when this is called, let me put it after this. Okay, so we're going to call this, which is going to call this, which is then going to do this, but this is going to go here and there. And then title is going to go there and there. And this is done for every single scene in this table. That's really cool. Okay. Now, we undefine this. So we've already done what we wanted to with it. We've created all these different arrays. Now, we are going to redefine it to call these ROM file things. So, well, I guess it hasn't been called yet, so just leave it. Is this called again? It is. Okay, so this next definition is for this area. So scene table definition. Handle none as special case for scenes without a title card. Okay. All right. So now we want to create a scene table array, where a scene table entry is the scene file, title file, this UNK, which I think refers to like unused bits or something. I think Romig pointed this out, but I can't remember exactly what it is. Then we have this draw config. Don't know what this is for, but define scene. So now this is going to get imported, which is going to bring in all of these defined scenes. In fact, it's going to happen in here. And then what is this going to get replaced with? Which is going to replace... So this is going to get put here. And then when we go into ROM file, let me copy this exactly. So for this entry, we get this. And same thing here. So let's go back to this table. So for Dodongo's Cavern, skip a line. Okay. And this is a lot. Alright, so name is going to get replaced here. And here. And then title. We'll replace this one here. What is this formatting then? What's happening here? Okay. So we're creating unsigned int pointers to where the ROM starts and where the ROM ends for the name and the title. Interesting. Didn't we already do that? DDAN scene segment ROM start. Alright, these are two different scenes. So if this was for if I did that, then this matches this exactly. Not sure what this is accomplishing. Well, I guess we're just creating an array of this. Oh, right, yeah, we're just creating an array of this. And so this ROM file, which is both of these things. Oh, we're just plugging those values in? Oh. So this is just a really fast way, not really fast, but this is a... I'll use, I think it was Yosefka's words. Like, this is a really clever way to define a ton of variables. Like, in this case, by doing... I'm gonna have to undo my changes in this. Let me git stash. Okay. By defining define scene as these, this is a shortcut essentially to taking all of this stuff and creating the arrays and creating all the arrays for all that stuff. And then we redefine it so that we can create an array that contains the stuff that we just created, including these arrays. So the first pass here creates all this stuff. It'll make more sense if I just did the same scene. Let me... Okay. Yeah. So this object right here is a struct. This is a scene table entry, where the first two things is the scene file and the title file. So the scene file is this. It is a struct. What is it? ROM entry? It's a ROM file, which is a struct that has a pointer to the start and end of this file. A pointer to the start and end of this file. So it takes this array, which we just defined because of the way that I had just mentioned, we defined all these arrays. Now we're defining an array of scene table entries, which has these ROM files, and the ROM files consist of the arrays that we just made, which is scene segment ROM start, and this, I believe, would go here. Oh no, these would go here. And then this would go here. not a fan of this auto formatting that's going on here. Sorry about that. Okay. What got accomplished? We created the scene table. And we created all the arrays for the scene itself and for the title of that scene. that was a lot in like, was that like 20 lines? Oof. There. All right, so we've reset. We have seen how all the scene stuff, I'm sure this is not all of it. We've seen how scenes are defined and a bit how we use these tables to define everything. Now I actually want to go back to define game state, because game state is used in the exact same or a similar way, where they define it to just give us the enum name. Define game state internal just gives us the enum name. Define game state gives us define game state internal, which gives us the enum name. So when we create this game state ID, we import this header, which calls these, which just gives us the enum name, which is the second one. So game state ID consists of only these things. Cool. Nice. Okay. Feels good to come back to this and make sense of it. Okay. All right, hey, now we can read this. Game state func is a pointer to a function that takes in a game state pointer that is a struct, maybe, that returns void, meaning nothing. Take a second to just chill. We've learned a lot, but I don't think that information is useful at this moment. But it was good to go through that. I'm getting more used to the syntax here. What's up, Gigi? You want to be on camera? Say hi to Gigi. It's a big boy. He talks a lot, let me tell you. Where to next is the question. Okay, so we gotta go back to this cutscene stuff. Scene layer might be an interesting rabbit hole to go down. I'm gonna take a second, step away for a bit, reconfigure sort of what I'm looking for right now. Feels like I've been wandering a bit and learned some stuff, but I gotta go back to my main quest, which is understanding what is telling Link to move and what is telling those camera movements to happen on the opening cutscene. So, I'll be right back.